Okay, so this is 5.5 day 2. And so on day 1, we looked at graphs and said, hey, where it crosses the x-axis, those will be the real, both the rational and irrational values. Also, we talked about what's it called? The way it crosses the x-axis tells you if there's going to be more than one 0 at that location. And so it's kind of a cute little thing as well. And so, all right, so let's look at today's lesson. Okay, so for today's lesson, it says solve it. Okay, and so again, if you can factor it or you can solve it not using synthetic division, go ahead. Okay, and so today, this one right here is big kid factoring. Okay, we can factor this by putting 2 parentheses and saying, okay, that's just x squared and x squared, and then minus 9 and minus 9. Okay, here we go. And then this would be x plus 3 and x minus 3. And same for this one. Well, there you go. We're going to get x equals 3 with multiplicity of 2. We're going to get x equals negative 3 with multiplicity of 2. Okay, and so if you looked at this graph, you would notice it's a happy U shape, arms going up, and it's going to touch the x-axis at both plus and minus 3. And that's what it'll look like. Okay, there are 2 real solutions, and each of them with multiplicity of 2. So it's kind of cute. And so I just want you to think, we're not trying to change up everything about math. We're just trying to say, can you find these values? Okay. All right, the next one. It says find the zeros of this function. Okay. Now notice this has 6 terms. Okay. It's not going to factor by grouping. If you tried to split it in half and factor by grouping, it is not going to work. So if I go ahead and put this in my graphing calculator, a somewhat interesting thing happens. You'll notice that it crosses the x-axis at 1. Okay, and that's it. You're like, well, you have to find 5 answers. But how it crosses the x-axis at 1 is rather peculiar. It has that fancy house kind of situation. Remember how you walk up a couple steps and then it kind of hesitates and drags a little bit and then it keeps going? Guess what? I believe we have a duplicate root, okay, an odd root of 1 that has multiple times that you can use it, okay? So if it has a multiplicity, you can reuse that value as many times as it is duplicated in that as answers. So we can try it first as 1. I got 1, negative 3, 7, negative 13, 12. Okay, this should actually be a minus, so just make that a negative 4. Okay, and let's see, you guys who have me, you may not see these in your notes. You may have to add this problem right here. Okay, this is one I'm gonna add in class. So if you don't see it in your notes, you might have to kind of watch me and kind of do this problem someplace else. So bring down the 1. You've got 1, you got negative 2, you've got negative 2 and 5, and then 5, and then negative 8, and then negative 8, and then 4, and then 4, and then 0. Okay, so notice it does work. Well, there's no way I can factor that one by grouping. It has 5 terms. Well, so if there were multiple rational locations where it crossed the x-axis, we could use a different root to do synthetic division to make it factor further. However, because there's a duplicate root, you can reuse that just like you would a room key at the Hyatt, okay, or the Hilton, okay? So you can reuse that same root if it appears multiple times, okay? And so it does. So we're going to say, let's do it again. Okay, so here we go. Let's do number 1, and then 1, and then that's, okay. So that's negative 1. Oops, hang on. Negative 1, and then negative 1, and then 4, and then 4, and negative 4, and then negative 4, and then 0. Now, here's the deal. I can technically do 1 more time, or I can factor by grouping. So I'm going to factor by grouping because I prefer that. And so we know x equals 1, okay, and you've got it at least twice. We actually know it has a bigger than that. It's going to be multiplicity of 3 because watch me, okay? If you've put the x's back in there, so you x squared minus 1x, okay, that would be cubed, pardon me. 1x squared plus 4x, and then minus 4. You factor that by grouping by doing x squared. You get x minus 1. You get, oops, erase that. Here we go. Yeah. Take out a 4. you're left with x minus 1. So your factors that are in common are x minus 1. Your factors that are not are x squared plus 4. So notice we do get the x equals 1 a third time, okay? And if you solve this last one for x squared plus 4 equals 0, you get x squared equals negative 4, square root it. You get x is equal to plus or minus 2i. So you're going to have basically one real root with multiplicity 3 and then 2 imaginary roots. So that's how you get your 5 solutions. So I like that question. It's a good one. The following one, number 3, again, I'm going to get back to my notes so I don't kind of botch it and so that I can work through it. If we graph this, again, we can't factor this as it is. So with hard factoring, we're going to do synthetic division to help us along our way. Okay, and so hard factoring will get us to be, let's see. Okay, so the factor we should do would be negative 2. Okay, and so I looked at my graph. I see it crosses the x-axis at both negative 2 and 4. And so if we try negative 2, you got 1, negative 2, 1, negative 18, and negative 72. And bringing down this, you get negative 2 is negative, oh, whoops. It looks like negative 4. And you get 8, and you get 9, and you get 18 powers of 8. Oh, wait, that's not going the right direction. Actually lies. It's going to be, I'm on the right track. We are going to get a negative 18 there. Okay, doing great. Negative 18 is negative 36. And then times negative, that's 72, which will be 0. That's exactly what you want. Okay. Now at this point, I noticed that there's another 0 at, it looks like 4. So we could factor by grouping like we did last question, or we could also just say, let's keep doing synthetic division. It counts as factoring. And so if we have another real 0, okay, then we can do that rational. We don't want to use irrational. No janky decimals there. You can use rational ones. Okay, so bring this one and you get a 4 and a 0 and then a 0 and a 9 and then a 36. Okay, and if we put the letters back in, you get x squared plus 9 equals 0. So x is equal to, x squared is equal to negative 9. So that's x is equal to plus or minus 3i. The other two solutions that we found on our graph are x is equal to negative 2 and x is equal to 4. So we're doing great, okay? There's 4 solutions. 2 are real and 2 are imaginary, okay? So I'm not sure that we need to do all of these questions that are on our notes. We've got 2 more left. So, I mean, I can demonstrate if you want to fast forward to the next part, that's completely fine. I mean, I'm just going to say, look at your graph. The first one is going to cross the x-axis at negative 3. The coefficients are 1, 5, negative 2, negative 40, and then negative 48. Bringing this down, you get 1, negative 3, 2, negative 6, negative 8. You get 24. Oops. So that's 24, and negative 40 plus that is going to give us a negative 16. And that's going to give us positive 48, which is 0. Again, if you look at this and put the letters back in, it'll factor by grouping. Another one of the zeros is going to be at negative 2, so we could do that as well. And so I'm going to just do it because it'll be fast. So 1, negative 2, 0, 0, negative 8, and 16 and 0. So you get x squared minus 8 equals 0. X squared equals 8. Square root both sides and put plus or minus. You get plus or minus 2 square root of 2. So x equals that. And then x also is equal to negative 3. And x is equal to negative 2. So I feel like that's a good question, okay? It's a valid problem to look at. The last one, to be honest, is kind of weird. It actually can factor by grouping. You know, so again, if you can factor these without using this method, you don't need to use synthetic and all the things. You certainly could. If there's a rational root that you've got, you certainly could. And so then plus 8, then x squared minus 9. So x squared minus 9 is one factor, and x cubed plus 8 is another one. You get x plus 3, and then x minus 3. And you get x, oh, it's cubes, cube factoring, x squared minus 2x, and then plus 4. And so you've got 3 of the answers are real, and 2 are going to be imaginary. So x is equal to 3, x equals negative 3, x equals negative 2. To do this, you're going to complete the square root quadratic formula. So 2 plus or minus the square root of negative 12 over 2. So it's going to be 2 plus or minus 2i square root of 3 each over 2. So it would be 1. So x is equal to 1 plus or minus I square root of 3. Okay, so there's two imaginary solutions. One is 1 plus I squared of 3. The other one is its conjugate, which would be 1 minus I squared of 3, and then plus or minus 3, and then 3. So 3 real solutions and 2 imaginary solutions. So that's a really good question. Okay, so the next thing we should look at would be, if I give you those solutions, can you write the function of it? Okay, and so we'll do that a couple times, and then, review what does the graph look like. Okay, so I'll leave that for you guys. Okay, so if you've got the solutions, all you have to do is write them as factors. So you do x minus each, so x minus 3, x plus 7, okay, and then x minus 5. Okay, FOIL any two together. If you get x squared, I'm going to get negative 5x plus 7x, so that'd be plus 2x, and then minus 35. And I'm going to multiply that by x minus 3. I always like to save an easy one for me for later. I also like to have the binomial first. It's your choice as to how you do it. So I've got x cubed plus 2x squared minus 35x, and then minus 3x squared, and then minus 6x, and then minus or plus, I don't know what 3 times 35 is. It's 90, and then something else added. So let me look and see what that's going to be. Say 35 times 3, 105. Okay, that wasn't too bad. So our function is going to be f of x equals x cubed minus 1x squared minus 35, 41 x, and then plus 105. Okay, so that is going to be our first problem. Okay, and so that's pretty cute. And then the next one, okay, 3 has a multiplicity of 2, so you have to write it twice. So you've got to write x minus 3 times x minus 3, and you have to FOIL this out. So you get x squared minus 6x again, so minus 3x, so it'd be minus 6x, and then plus 9. Okay, you can show all your steps, but FOIL it out. And then the thing is this. Remember on day 1 where I said, hey, if you've got imaginary or irrational values, their conjugates always show up. And so the thing is this. If the square root of 5 is a solution, so will negative square root of 5 be. Okay, so if you had 2 plus 3i, so would 2 minus 3i. Okay, so if you had 2 plus the square root of 5, it would be 2 minus the square. Those always show up. So if just because I tell you one, its conjugate will always be a solution as well, and you have to just factor that in. And this is not something I made up. I remember being miffed at Mr. Wiederman when he told me this fact. I was like, what is wrong with you people? The truth is, you have to realize that its conjugate always is also a solution. But it's nicer because they play better together, like your dorky cousins who like to play with Legos. So you do x minus the square root of 5, and then x plus the square root of 5. Okay, because you do x minus subtract each one. Now, notice their conjugates. Awesome. We get a binomial when we do that. And so the truth is, when you do this, you're going to get x squared. It's going to be plus x squared of 5 minus x squared of 5. Okay, the middle terms will go away. And then minus the square root of 5 squared. So if you do the square root of 5 times the square root of 5, you get the square root of 25, who is 5. Now, if you solve that for x, you would get plus or minus the square root of 5. So if you are losing your mind, you're like, what am I getting? Okay, now the thing is, if you solve each factored form, you should be able to get back to your answers. Okay, and so it should be true. Okay, so here we go. Now we have to refoil this out. So we're going to get x to the 4th minus 6x cubed plus 9x squared. And then I'm going to take negative 5 times all those three things. So it's negative 5x squared plus 30x, and then minus 45. So our function is going to be x to the 4th minus 6x cubed plus 4x squared plus 30x, and then minus 45. Okay. So that's kind of cute. Okay. Let's keep trucking. Okay. We've got 2 more to do, and they're a little weird. Okay. So don't lose your mind. Okay. So again, with real numbers, with rational numbers, you don't know that just because 3 works doesn't mean negative 3 works. But in this case, they gave us 3 and negative 3. So that was kind of a gift. So you do x minus negative 3, that's x plus 3. If you have x, the 3 is x minus 3. And then 2i, again, its conjugate friend is also a solution. okay, which is good because then you've got conjugates to multiply. So you do x subtract 2i and x plus 2i. Always pair conjugates together if you're foiling. So this would be x squared minus 9. Again, the middle terms of negative 3x and positive 3x will go away. Same with i's. It's going to be x squared minus 2xi plus 2xi. Nobody cares. And then minus 4i squared. Now, do you remember that I squared is negative 1? So negative 4 times negative 1 is 4. So this would be x squared plus 4. We times it by x squared minus 9. And you get x squared minus 9x. Oh, that'd be x to the fourth, pardon me. And then plus 4x squared. And then minus 36. So our function is x to the fourth minus 5x squared and then minus 36. And I've asked you to solve that a bunch of times to be like, hey, factor it up. And it's just big kid factoring. It's not that big a deal. Okay. All right. The next one. If 0 is a factor, do you know how you'd write that? You just write x. Okay, it says it's multiplicity of 3, so we need x cubed. Okay, now 3 plus I shows up, so does its conjugate 3 minus I. Okay, so you have to do x minus each. Okay, and because of the way this goes, you just do x subtract, and then you just write the root. You do 3 plus I, and then 3 minus I. Okay, it works this way. There is a distributing way you could do it, but it's just x subtract and then write the root. Okay. And then the thing is, you're like, I do not want to FOIL that. I get it. I don't either. So what I want you to focus on is grouping things. Sometimes if you look at things in a group, it makes it easier. Do you see how it's a thing plus I and a thing minus I? That means it's a conjugate, okay, which makes it a lot easier. So you're going to say it's x minus 3 times x minus 3. And then you're going to say the middle terms are going to go away. And you're going to do minus I squared. So it's a kind of a big kid conjugate. Okay, you're like, do we have to be so big? I'm like, yes. So it's going to be x minus 3 times x minus 3, and then negative 1 I times positive I. Okay. And then to FOIL this, you get x minus 3 times x minus 3. That's x squared minus 6x. So it's minus 3x again, minus 6x. And then plus 9. And then minus I squared. And I squared is negative 1, so it'd be plus 1. And so it'd be x squared minus 6x plus 10. And then we got to bring down the x cubed and distribute it. So you get x to the fifth minus 6x cubed plus 10x. I botched something. This would be to the fourth. That'd be the third. And so this is our function. Okay, so it's kind of cute. Okay, so the next part talks about the graph, and you can peek at that and see, okay, where it crosses the x-axis, where there's a double root, where there's an odd-powered root, where there's a turning point, the end behavior, etc. Okay, now let's write this graph. And because they give us valid points, we can be a little bit more precise here, which is kind of cute. We see it crosses at -2. So if x equals -2, that's x plus 2. We see it crosses at 1, so that's x minus 1. We see that it crosses at 5. So that's going to be x minus 5. Now, the thing is, we know it's going to be a positive coefficient, but we don't necessarily know what that coefficient is. Okay, so here's kind of something you'll do more next year. And so you're like, I've got this. There's no duplicate roots. How do I find that coefficient that sits in front of here? Okay, most of the time we don't really care, but if I give you an actual graph, I may be like, can you find that? So what we're going to do is we're going to say, let's FOIL this out, okay? And I'm going to do these two together. I'm going to get x squared minus 5x minus 1x is minus 6x, and then plus 5. And then I'm going to multiply it by x plus 2. I get x cubed minus 6x squared plus 5x, and then plus 2x squared, and then minus 12x, and then plus 10. So you get x cubed minus 4x squared, minus 7x, and then plus 10. We know there's a coefficient in front of here, and we know it's positive. The question is, like, what is kind of the vertical stretch on here? Okay. And so the way you do it, it's not that hard. You basically take a point from the graph, and I like points have zeros on them, so I'm going to pick the point 0.05. That's x and y. If we plug in those values into this equation right here, we'll be able to find a. And so if y is 5, okay, and then x is 0, we've got a And then this whole thing becomes 0 squared minus 4 times 0 is 0, minus 7 times 0, which is 0, and then plus 10. So this is 10. And so the thing is, if you had, it's a little weird looking. If you just reverse this order, you get 10a. To solve for a, you divide by 10. And so a is equal to 1/2. So your function actually would be, if you really want to be precise, would be f of x or y is equal to 1/2. And then times, you could put a half right here. So it'd be a half x cubed minus 2x squared minus 3.5 or 7/2 x, and then plus 5. So there you go. It's kind of a good job. Okay. You'll do that more next year. All right. Thank you so much. Have a good